In this movie, we will be showing to you our knowledge specification and maintenance tools, which are used by the knowledge engineer and medical experts to create the medical knowledge library. Part of our unique technology is the medical knowledge library, where we store the relevant medical concept used by our decision support software. We build the medical knowledge library by converting the medical knowledge, which is in textually based guidelines, to our computer format. We do this by using our unique tools and methodology via the collaboration of the expert physician, clinical editor, and knowledge engineer. We will now show you these tools. Using our tools, we will now create a new guideline. After logging into our digital guideline library, we will now create a new guideline, which in this specific case, we will call hypertension. Once the new guideline is created, our first step is to locate the source guidelines and attach them to the new guideline. In this case, we are searching for two hypertension guidelines and have attached them to the new guideline, as you can see from the National Guideline Clearinghouse. Once the new guideline has been created and attached, the clinical editor adds new knowledge concepts. Once the relevant information is found inside the guideline, the relevant information is added as a new knowledge concept and marked up inside the guideline. As you can see, the clinical editor is now adding grade 1 hypertension. The relevant text is selected, marked up, and on the bottom of your screen is added to the guideline. This allows us, of course, to keep track of the relevant knowledge concepts, their place inside the guideline, where they come from, and allows us to maintain the knowledge concepts should there be any requirements later on to change the specific knowledge. We then, of course, can go back and show exactly where each of the knowledge concepts come from inside the. The graphical interface is used by the clinical editor to create the detailed specification of the medical concepts. The editor adds the relevant knowledge items to the guideline knowledge base according to the textual description and includes the relevant properties of each knowledge item. The raw data items are then connected to the high-level concepts with the relevant logical constraints. The result is that the free text at the right-hand side is converted to the correct knowledge concept. To shorten the time of specification, the editor can search for concepts that are already defined in the knowledge library and use them in the guideline specification. Then she can modify these existing items to the current guideline definition. The editor uses the systolic blood pressure and diastolic blood pressure parameters that were added from the library for the clinical specification of the different hypertension concepts. The detailed specifications created using the graphical interface are then translated into our clinical decision support software format that is used when connected to the patient's data. As you can see here, the final parameters are being filled in. The next step is to define the clinical workflow. For that, the editor uses our graphical flowchart editor and specifies the subplans which comprise the process of the guideline application. In our example, the clinical workflow comprises the blood pressure measurements. The workflow instructs the clinician either to continue with the treatment or to discharge the patient, depending on the actual results. The user can further describe each of the subplans and create a more detailed representation. In our example, she adds a subplan to specify the required instruction and medication. To create a standard representation, the editor uses an interface to browse a controlled medical vocabulary such as RX norm and selects the specific medication which attaches the relevant code to the medication subplan. In the bottom left-hand window, we show the hierarchical structure of the guideline. The user can navigate through the hierarchy and see the entire plan represented. We also have an additional user interface, the plan hierarchical diagram, where the editor has another convenient tool which visualizes the guideline. This is useful in explaining the clinical workflow to the system's users. Our next interface is where we connect the medical concepts and clinical workflow in order to create the formal knowledge representation which is used by our software. This is the step where we create the actual computer code. The editor connects the defined concepts to the relevant sections in the body of the guideline. In our example, grade 3 hypertension. In the background, the system has generated the XML code, which is the formal representation according to the ASBRU specification language. In the upper left window, there are options to specify different guideline elements, such as relevant filter conditions. Here the editor connects the adult concept as the eligibility criteria of the guideline. The next stage in building the guideline is validating the syntax and semantics. Here the editor runs the guideline in our debug mode of the application engine. The system prompts for the input according to the guideline and provides the corresponding recommendations. In our example, the editor has validated one of the clinical paths of the guideline. Now that we have built our demo guideline, we will show a complete existing guideline. We will choose chronic heart failure. The full diagram shows that this detailed diagram, as we can see in the plan hierarchical structure, has more than 100 subplans. And the plan hierarchical diagram shows that it covers more than 40 clinical pathways. These pathways are detailed and cover different stages of the treatment and have multiple scenarios.